Okay, good afternoon, everyone. Welcome back to our session on enlargement. So we're going to be doing a little recap quite quickly as we look at the properties of enlargement. All right. So one of the properties that we discussed in our previous session was that the length of each side of the object, otherwise called the pre-image, so you may see those words interchangeably. So the length of each side of the object and image remain in the same proportion to each other. Now I want to stop here and just, do a little bit of explanation based on what was happening in the previous session. So I noticed there were some persons who were a little bit confused about what was happening as it relates to the relationship between the lengths. They were actually seeing or saying that, 2 units or 1 unit or 3 units were being added to the lengths. But when we talk about same proportion, we're actually looking at a multiplicative relationship. And you might be saying, Miss, what does that mean? What we're saying is that what's happening to the sides or the lengths when we actually have an enlargement is that the lengths are being multiplied by the scale factor. So for example, if the scale factor is 2, then what's happening is in order to get the lengths or the distances as it relates to my image, all of those lengths pertaining to the object are multiplied by 2, all right? Similarly, if, for example, I have a scale factor of 1/2, then a similar thing will happen. All the lengths or distances pertaining to the object will be halved, all right? So for example, if I have a length that is, say, 3 units on my object, and the scale factor is 1/2, then the corresponding length on my image is now going to be 1.5 or 1.5, all right? So we're seeing the distances being halved. So that's what we mean when we speak about the length of each side being, and on the object and the image being in the same proportion. So pay attention to that phrase, the same proportion, all right? And we also said that each line in the image is parallel to the corresponding line on the object, all right? And we had explored that earlier. If you missed it, just check back in our previous video and you'll see the exploration there. We also explored the fact that the angles remain the same in the object and in the image. However, as we said with the first point, the sides are in the same proportion to each other. And so we'll notice that the sides will not be exactly the same. The sides on the image will not be exactly the same as the sides on the object. Unless, of course, our scale factor is 1 or a -1. And we did say that in the previous session. So object and image, therefore, are similar. We also said the scale factor gives us some important information. It will tell us if the image should be larger, smaller, or the same size. So if, for example, our scale factor is 1/2, or maybe even -1/2, once it's 1/2, whether positive or negative, and I'm just using 1/2 as an example now, then the size, the image is going to actually be smaller. If we have a scale factor of, for example, 2, or maybe even -2, then the image is actually going to be larger. If we have a scale factor of 1 or -1, then we'll have the same size object and image, all right? Now we said though that the orientation of the image will be affected by the scale factor. What do we mean? If the scale factor is negative, then the orientation of the image is inverted. While if it's positive, the orientation would be the same, all right? We also said congruence, we looked at that word. We only have congruence between object and image when the scale factor is 1 or -1. So just in case you missed it, I want to zoom in a little bit more on the positive versus the negative scale factors. So whenever our scale factor is positive, yes, we are expecting 2 things in particular to happen. All right, whether it's +0.5, +2, +3, whatever it is, once it's positive, we are expecting 1, that the object and image will lie on the same side of the center of enlargement. I'm not sure why it's not coming up on screen at the moment, but the object and image are on the same side of the center of enlargement, as we're seeing on the diagram here. So we would have an object right there, smacked in the middle, labeled object. And if we were to use a scale factor of 2, we're seeing image number 1 to the right of the object. All right, and if we're using scale factor of 0.5, we see image number 2 to the left of the object. However, look at where my center of enlargement is, right down at D. And we look that all of these objects and images are lying on the same side of the center of enlargement. In addition, the orientation of the object and image are the same. I remember we said we're talking about how they are turned pretty much. All right. So for this one, QR is on the base of the object, and we're seeing Q prime R prime on the base of image 1, and similarly, the Q double prime R double prime being on the base of image 2. Now we talk about a negative scale factor. 2 important things happen as well. All right, and it's still in relation to which side of the center of enlargement does the object, or do the object and image lie. So in our diagram, we're looking at our object on screen, PQR, and for example, image number 1 has a scale factor of -2. And what we're seeing here is that the image is on the opposite side of the center of enlargement. Not only that, but it is inverted. All right. And as we look at image 2, which has a scale factor of -0.5, we're seeing that yes, the lengths have been halved, but because the negative sign is there, the image is now on the opposite side of the center of enlargement. And again, the image is inverted. All right, so this is where we were when we ended our last session. Now, as we continue, I did say to you that we are going to be exploring how is it that we perform an enlargement. And I want the chat to be lighting up. Whenever I ask a question, feel free to answer in the chat, or if you want to unmute, go right ahead and raise your hand and I'll identify you and you can unmute. All right, so how do we go about performing an enlargement? In our previous video, we would have looked at, using GeoGebra to perform the enlargement, and would have seen the objects and images popping up. But there comes a point when we have to be able to perform this enlargement manually. How do we do it? So we're given the task to draw a trapezium, A prime, B prime, C prime, D prime, and that trapezium would be the image of ABCD, which is on screen, after an enlargement of scale factor 3. So note the scale factor, students. Scale factor 3, about the 0.86. So before I get into the enlargement, I want you to tell me in the chat, based on the scale factor, what do you expect to happen with the length as it relates to the object? What do we expect to happen to the length? So what's going to happen to the length when I compare the length on the object to a corresponding length on the image? And Danae is saying longer, but I need something more. Paying attention to the scale factor. Shanice, change? Oh yes, it will change, but how? Think about it and see if we can figure it out. How will these distances and lengths change? It is increased. Well, surely it will be increased based on the scale factor, but how? Danny, longer by 2, you sure? All right, so something to think about as we look at how it's done. So when we're through, we're going to speak again about the scale factor and what it does and what it says to us about the lengths. All right, and if you see me moving on, my colleagues, please remind me that I need to speak to this once I'm through with how to perform the enlargement. All right.
Okay.
So let's look at how to perform the enlargement, and we'll speak back to how important the scale factor is, what it tells us. All right, or as we're doing it, it should come out, in fact. All right, so we're looking at scale factor of 3. We were given a center of enlargement. So the first thing we need to do is to identify and mark that center of enlargement. All right, so it was the 0.86, and it's now on screen. That blue dot right there should be labeled, and the label will come up in a few. Wonderful. Now, listen carefully, guys. Listen carefully. The scale factor, remember, the scale factor says to me that all lengths will be multiplied by whatever the scale factor is. Now, in this case, my scale factor is 3. What that means is that all the lengths will be multiplied. Notice the operation I'm speaking about will be multiplied by 3. So distances will now be 3 times whatever they were before. Hope I'm speaking very slowly so that you can understand and you can absorb what it is I'm saying. So let's see how this plays out. So let's take, for example, the point A. So I'm going to draw a line segment, and I've called it an extended line segment because we're going to go beyond point A. All right. So we're going to be drawing an extended line segment from the center of enlargement through a vertex of the object, and I've chosen A to be the first one that I do. All right. Now remember, see how many times I'm repeating it? The scale factor 3 means all distances have been multiplied by 3. So whatever the distance from the center to A is, I need 3 times those, or 3 of those, to get to where A prime will be. Now I needed to watch the animation carefully. All right. And we're going to count as we're seeing the distances come up. So let's check now. 1, all right. So there's a distance from the center to A. That was 1. All right. It's doubled now. But we can't stop there because the scale factor is 3. It needs to be tripled 3 times. Do it again for me, miss. Let us get to count again. Go ahead. 1. 2. So that's 2 times. 3 times. Good. So right there, I'm going to put the point A prime. Let me know if you got that before I do any other points. Let me know if you saw what was happening and if you saw how the distance was tripled or 3 times. All right, Acacia, awesome. Anyone else was paying attention? You have to let me know if you're seeing it because it's going to affect what we do next. All right, Danae's seeing it. All right, just in case you missed it, thank you, Christopher. We're going to do B. All right, so we already dealt with A prime. We're going to do now B. So let's look at the distance. So we have our extended line segment, and now we're looking at B. Good. So we need 3 of those distances from the center to B. Let's check, because our scale factor said 3, so it's 3 times. All right, so all distances must be multiplied by 3. Good. 1, all right. Multiplied by 2 now. Multiplied by 3. Awesome. So right there, I am going to put B prime. Anybody else see it? So others would have responded about A already. Anybody else see what happened a while ago with B? So not Christopher, not Danny, not the others who respond. All right, Galaxy, you saw it. Good. We're gonna do the same thing. Thank you, Abby. So we're gonna do the same thing now, and we're gonna focus on D. All right, so since we already have the extended line segment there, we're just gonna do D now. Notice now, we're looking at the distance from the center to D. That's what we have to focus on at this point, because we are working with finding the image of D. Remember now, all our distances must be tripled, or in other words, multiplied by 3. All right, so let's see that now. So we have 1, it's just brought the other one, 2, and then the other one now. Oh, you're doing it again. All right, go ahead. 1, 2, 3. Awesome. Thank you for that notice in the chat, Miss Harris. Right, so it's the distance from the center of enlargement to a point on the object. We are checking that, and we're getting 3 of those to get to the image. All right, to get to the corresponding point on the image. Good. So we know where D prime is. So we have C left to do. And C is pretty easy. I can ask you now about even your units. So what's the distance from the center to point C? So from the center of enlargement to the point C on the object, what's the distance there? Let me see the chat blowing up, because you have to tell me that you didn't eat and fall asleep. All right, Acacia, you are alert. Let me see who else is. I'm gonna blame it on the internet, but I don't see. All right, Galaxy. Good. 2 units, all right? So tell me now, how many units do you expect to have when we check the distance from the center of enlargement to C prime? Jeez, I'm a case there. Couldn't even finish asking the question. I like it though, I like it. 6, so tell me how you get this 6, because you're gonna have to tell me how. How did you get this 6? Because I want to ensure you get the relationship. How you get the 6? All right, good. So I see the multiplication coming out. So she said 3 times 2, in other words, the 2 units, she multiplied it by 3, which, as we said earlier, 3 is our scale factor.
Already did, Miss. She told you, Miss 3 times 2. Acacia told you long ago, Miss. She's ahead of the game.
Okay. Thank you. All right. So let us check, because we want to know if Miss make mistake, you know. So let us look what is happening. So let's go, Miss. So that's 1 time, 2 times, 3 times. Let us check if it's 6 units for true. Look at it and tell me if it's 6 units. So you check and tell me if it's 6 units. I go and blame it on the internet when I don't see anything coming in the chat, because I don't believe students ignoring or drop asleep. Okay. All right, Christopher. Okay, Danny. So 6 units. Awesome. So we know where C prime is. Good. So let's label it. And once we have done that for all our vertices, then we know that we can now draw our image A prime, B prime, C prime. D prime, and I want to drop it right here now. Let us look at the length on the trapezium itself. So when we were doing it, we're looking at the length or the distance from the center to a point on the object, and then we went to find the point for the image. But I want us to zoom in now on, for example, let's take AB. So look at AB on my object. What, or how many units rather, or what's the distance between A and B, or what's the length of the line segment A, B? Danny, nobody let me send you a vertical, you know, a virtual, sorry, you know what, you know. I said A, B, no, not A prime, B prime. I looking at object and you look like you're looking at image. So let's fix that up. What's the distance, or what's the length of AB? 1 unit. Awesome. So now let's go over to the image and let's look at the corresponding distance A prime, B prime. What did we have there? 3 units. Are we seeing the multiplication by 3 coming out? All right, Shanice, you have it locked, it triple. In other words, it's multiplied by 3. Last one we're gonna check is DC. What's the length? DC.
Six.
Galaxy, sure. DC, I said, you know, not D prime, C prime. Let me clear my throat. It's still about 2 units, Mr. Galaxy. All right, so the length DC is 2 units. All right, so now all the people who are ahead of the game and heard what they never did want never supposed to hear. Let's check now D prime, C prime. Now you can tell me what's that length. Tell me if you see the multiplication coming out. So DC was 2 units long and D prime, C prime is 6 units long. Let me know if you see it. Good. So I'm happy we cleared that up. So whenever you are asked to perform an enlargement, this is what you're gonna do. So remember, you must first locate your center of enlargement, and then you're gonna have to do each point individually. All right? Okay, now there are times when the transformation, and I'm making it broad now, when the transformation is already performed for you, it's already done, all right? And you are now being asked to describe the transformation, all right? I remember, well, if you missed the session 1 on enlargement, then you perhaps missed how we describe an enlargement. So just to remind you, for describing an enlargement, we need the scale factor and we need the center, all right? So we need the center of enlargement and we need the scale factor, okay? So let's look at this one. Before you bring that up, Miss, let's look at this particular question. So we have our object PQR and we have our image P prime, Q prime, R prime, our image there. Now, let me ask you, based on what you're seeing here, can you identify if this is an enlargement? And you're going to tell me how you know it's an enlargement if you say yes. And if you say no, well, I'm still going to have to explain why you say no. So is this an enlargement, first of all? And I know you're probably saying, ha, 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 the topics are finding the center of enlargement. That is why you're going to have to explain to me how you know it's an enlargement if you say yes. So let's go. Remember, you can unmute. It's not an enlargement, Acacia. Let us see. Anybody else? Anybody agrees with Acacia? Danny, you're saying it gets smaller. Interesting. So which transformation speak about changing in size, smaller or larger? Galaxy saying it is an enlargement. How you know, Galaxy? How do you know? How do you know? Let me see this one in the chat. Hold on a second. Let me see this question. So the larger one would be at the bottom. You sure? Okay. I'm happy that I have this question here now. Larger one with the image if it was enlarged. So again, if you missed the first session where we looked at definitions and so on for enlargement, remember we said, even though it is saying enlargement as the broad topic, it speaks to whether the figure is getting larger or smaller. So it's gonna be the same shape, meaning it's gonna be similar, right? The size is what's gonna be different, all right? So remember those key things. So I know it, I know sometimes we see enlargement and we say, oh, enlargement, that means it's enlarged. And we say, oh, it must get bigger. Remember we said earlier that, or in the previous session, that an enlargement speaks to the shrinking as well, all right? So let's speak to what some persons were saying about if it's an enlargement, then it should be on a particular side or something. Let's see if we can clear that up. So yes, it's an enlargement. Let me just put that out there. It is an enlargement because we're seeing a change in size. And we're seeing that, the shape hasn't changed, but the size of it has changed. But I have another question, because if it's an enlargement, we are expecting scale factor. So just putting it out there by observation, would my scale factor here be a positive scale factor or a negative scale factor? Spoke about some clues earlier. Hey. All right, so everybody lighting up the chat with negative. Awesome. Good. I'm glad you're seeing it. So even before you start to answer the question one, you have identified it's an enlargement and you already have in your head that this scale factor is negative. All right, so let's proceed. How do we find the center? So we don't know what the scale factor is yet, you'll get there, but we know it's negative for sure. So let's talk about this. Finding the center of enlargement is one of the easiest things, trust me. All right, so we're going to be using a line segment to connect each pair of corresponding vertices. A mouthful, what we mean? We're going to be connecting what? P to its corresponding vertex on the image, which is P prime. And then we're going to be connecting R to R prime. And we didn't bother to connect Q to Q prime. That's literally on that darkened line on your graph paper. All right. And really, you can do two pairs, but just to be safe, I recommend you do 3. All right. Now, where is the center of enlargement? It is going to be located wherever those line segments intersect. So anywhere you see them intersecting, that's where the center of enlargement is. Can anybody tell me what the coordinates for this center of enlargement is? Just type it in the chat and let me know the coordinates. All right, so I'm gonna correct what I'm seeing here, but I'm also gonna encourage you. I know we have we had a session on coordinate geometry. I'm not sure if Mr. Leamy will be able to bring that up and put in the chat for future reference. but I'm just gonna clarify this part. So I saw some things happening in the chat there. So let's just clear this up. Remember, when we're giving our coordinates, we start with our x value. So I'm over here moving my mouse like crazy. Forget I'm not the one sharing screen. So this is Cameron Edwards. All right, so let's look. Let's get to our point. Let's put the arrow over our point, right? And we're going to go up or down till we get to the x-axis. So clearly it's not up in this case. So we're just gonna trace from that point straight down. And we're gonna read off what that x value is. 0. Awesome. So the first value in your bracket is supposed to be a 0. Let's see what the y value is. So go back up to the point, and we needed to go left or right until we get to the y-axis. But guess what? Point already on the y-axis. We don't need to go left or right. We can literally just read off that value of 2, positive 2. Yes, it is. It's above the x-axis. Remember, those values would be positive, right, Acacia? So again, I'm going to ask Mr. Leamy, while we're in the session, to just drop the link to that session once he finds it, so you can copy it and have it for later referencing. All right, so our center of enlargement here, Missy can bring it up now, is that point 0, 2. All right, let's continue now. Okay, so now that we have found the center of enlargement, we are gonna look at how to find the scale factor. How do we find the scale factor? Let's see. So we're gonna find the length of a side on the image. So remember now, because we want to see what happened to get the image, we're gonna start there, all right? So we're finding a length, the length of a side on the image, or if you think it is easier, you may find the distance from the center of enlargement to a point on the image, all right? So for this question, I figured it's easier for me to get a distance that is either vertical or horizontal. In this case, horizontal. So I didn't bother to look at the length of the side on the image. I chose to look at the distance from the center, which is C, to a point on the image. All right, and I chose the point Q prime. All right. And what unit, what's that distance from C to Q prime? What distance is that? 1 unit. Thank you, Dania, on the ball. Casey, Lerona? Oh, okay. All right. So no, that's fine, that's fine. I know the fingers working fast, and I mean, they're right next to each other. All right. So we notice that the distance from C to Q prime is 1 unit. Let's check now what's the distance from C to Q. 2 units. So careful with that doubling. And I didn't see who, the chat is moving a little fast. So careful with that doubling, because remember here when we are actually finding the scale factor. So when we looked at the doubling and so on, we were actually given the scale factor, so we knew what happened. Here we're kind of working backward. So we are now working from the image. Yes, so we have to take that, you have to take that distance first and look, you're examining it now to see what was done from the object to get to the image. All right, so just be careful with that. Good. So it wasn't a doubling, it was actually divided by 2. Awesome. So you have to be very careful, all right, and pay attention to those little things that can throw us off. many times. So let us pay attention to these things that are on the left here. So having identified our length or our distance from the center of enlargement to a point on the image, we're now dividing that by the corresponding distance or length on the object. All right. So we had 1 unit. Acacia, I'd prefer if you say the image, the length on the image is half the length on the object. All right. Yes. All right. Thank you for that, Miss Harris, in the chat. So for those who probably are on YouTube, you're pointing out that division by 2 is the same as multiplying by half. Awesome. So let's perform this division and see what it is that we get as our ratio. So what's the ratio? Remember we said we talked about proportional earlier. So that should drop in a little ratio thing in your head. So let's go. The distance C from C to Q prime was 1 unit, and the distance from C to Q was 2 units. And of course, if we perform that division, we get a half or 0.5. Somebody tell me what is wrong with this. What is wrong if I say my scale factor is a half or 0.5? Suppose I put that on the paper. What is wrong with it? Well, good question, positive or negative, but guess what? If I don't see a negative sign there, you know, it automatically means it's positive. I'm sure you know that. So I won't even debate that point. So, divided, who is that? It didn't say if it is divided. All right, so remember that we are working backward now. All right, so we are trying to find the scale factor Acacia, and so for this we're dividing. All right, so we're using the fraction bar. Please hover over the fraction bar, miss. We're using the fraction bar to indicate the division operation for this particular question. All right, so positive or negative is right. So if you don't put any sign there, you're saying it's a positive scale factor. We already discussed at the beginning that this scale factor is negative based on what we would have observed. And so therefore, our scale factor for this question is Chinese, but we have the value, so you can just outrightly say negative 0.5 or negative a half, but I get you. All right, good. Awesome sauce. So the last thing we're going to look at for this segment on enlargement is something that is very, very critical. All right. So we would have been looking at lengths, and I hope you were paying attention that I kept saying the lengths and the distances and so on. But we have another little part, maybe about 2 slides to cover this. How does an enlargement affect the area of the image? Because you may be asked that. So let's see what happens. We are going to do, take about 5 minutes to wrap this up, and then we do the questions. It changed, then Shanice, but it has to change. It must change. It has to change, but we want to know how. So let's check. So type in the chat for me. First thing, what's the area of the object? So they are labeled object, image A, image B. So we talk about the object. What's the area of the object? All right, Danae's out the blocks. 3, source of 3. I'm going to put it down to Canberra. All right, but you sure is that power you want for area? All right, so 3 square units. All right, so you would have said square units. All right, so I think it can pop in. So you'll see, right? So 3 square units. So if it's centimeters, then where unit is, you would put your cm abbreviation. All right. So 3 square units. Good. Somebody now look at image A. Let's put our focus on image A. Image A has a scale factor of 2. You know, I'm not smart. I should just hide this and ask you, because I know you're going to count. But anyway, what's the area of image A?
I'm delaying, just tell me when to bring them in.
Yes, miss, no problem. I'm waiting on them to answer. All right, Danae is saying 12 square centimeters. All right. I don't know, you know. I can't know until I see more answers in the chat. So, because I'm not talking to Danae alone. No, so Danae and I are having a private convo. First of all, 12 centimeters. All right, so be careful now. Remember, we're looking at area. So that definitely needs a square on it. All right. I'm going to put it down to the typing thing, but I still have to point it out. All right, so 12 square units. And again, if you're using centimeters, fine. 12 square centimeters. Awesome. So you can bring that up now, miss. So notice now, we're actually going to put this together in a table. All right, no problem. We want to put this together in a table, but I want you to take note that the scale factor is 2. And the area never double, clearly, because we have been doubling from the session start. We did some doubling and we know what double mean. It certainly never multiplied by 2. So we're going to have to figure out what's going on here. But while we do that, let's look at scale factor 3. You tell me quickly now, because we want to wrap this part up in a minute or 2. So quickly type in the chat, what's the area of image B? Notice now the scale factor is 3. Hold on, okay. 27, 20, all right. So I don't want to spoil this person's
Can I
name.
ask the students, how are they getting the answers? What
Sure.
method are they using? The student,
But before you ask that, somebody type 27 raised to the second power. I just want to, I can't find the name, but just be careful. Remember, it's the it's square centimeters and not the value there that is squared. I don't want to spoil this name, you know. And I can't see the last name. But the person who typed 27, you know, he didn't put any units on. Mullings, yes. So just be careful. All right. And Bree, be careful. All right. How are you getting it now? Okay. All right, so I see a multiplicity of responses. Some persons are counting the squares, so be careful now, they are not blocks, not talking about volume, but you're actually counting the squares. Let's tidy up the language a bit. So some of them were counting the squares. Others said they actually cut the shape in 2 rectangles and did the multiplication of length and width and then put it back together. That's what I'm seeing from the chat. All right, so let's bring up the area, miss, and just tidy this off quickly. All right, so it's kind of hard to see from this, so let's bring it up in a table, and this is the last slide for this portion. And let's see if we can figure out what was happening. See if we can catch on to see what was happening. How does the area of image A compare to the area of the object? So area of the object was 3, and the area of image A was 12. Well, this clearly not double. So I wonder if anybody can tell me what was happening here. it triple, it fople, oh, this streaming live, it quadruple. What is it? What's happening here? Quadruple. Okay, colleagues, it quadruple. I'd say multiplied by 4. All right, fine. So we're seeing that the area of the object was actually multiplied by 4, but the scale factor was 2. And if I was typing in the chat, I would send one of those thinking emojis. But I'll make the sound. So let's look at image B. 27 square units, but the object was, the area on the object was, of the object, sorry, was 3 square units. What's happening here? Times 9. That's what I see to Galaxy, but the scale factor was 3. So what is happening here? Who can tell me? What's happening here? Look at those values that are in red. They're in red for a reason. And look at your scale factor and see if you can find anything going on right there. So notice something. You sure is that give you 9? Acacia, double check that, please. Remember, it's multiplication you have there, you know, not adding, you're multiplying. Okay, so that first 3 is the area of the object. So what I want you to speak to me about, Acacia, is not how to get the 27 in total, but speak to me about the 9 and how it's related to the 3 and the 4 and how it's related to the scale factor of 2 and so on. Not quite sure I understand what you're asking, Janice. Yeah, not quite sure. So maybe I made a typo error, but I can't really pick it up. But in the interest of time, I'm gonna just share with you what I saw. You can go and think about it and say, All right. So what do we know about 3 squared is that Galaxy Jesus. Your fingers couldn't like fractions of a second faster. All right, but yes, 3 squared is 9. Good. So then what's the relationship with the scale factor then? So 3 being the scale factor is K, then we're expecting therefore that on the image, the area of the image is gonna be K squared multiplied by whatever the area of the object was. In this case, it's 3, but it's not always gonna be 3. Maybe the area of the original is 10 square units. And if it's 10 square units, whatever the scale factor is, I need to square it and multiply it with 10 in order to get the area of the image. I know this may take a little mulling over, but remember this is on YouTube. You can always go back. You can always watch it. You can always pause it, think through it, you know? Yeah, all right? But thank you for joining us for this last session on enlargement. In our next part, we will be looking at 2 questions that look at reflection and enlargement.